Okay, so my screen is visible.
Yes, ma'am.
Okay, let's begin. So, after covering all the basics of Python programming language, which are basically required for the understanding of how we can do the data analysis using Python programming language, right? So, pandas is one of the most important library in Python that is used for data analysis because it has so many functions and methods which using which we can load the large amount of data into our programming environment, and then we have various methods using which we can efficiently manipulate these large data sets, right? So you can say when we are working with the pandas, so there are basically two data structures, the two most important data structures which we are working with. One is called as the series, that is basically a one dimensional array, right? So how does it look like you have worked with a list also, right? So you know what is list. This is, list is also one dimensional array, and along with the list, in the list the data was stored in a sequence. So here also in the series the data is stored in the form of a sequence only, and the indexes are there, right? So you may have the predefined index, and you, if you wish to change, you can change these indexes according to your requirement also. So this series can store any kind of data like integers, floats, Python objects, or anything like that, right? So then along with the series, the most important data structure that we use when we are loading the data into the Python, and then we want to process particular data, we want to analyze that data, we want to do any kind of processing, pre-processing of that particular data, the two-dimensional data structure that we use, right? So how does it look like? So here you can see your series looks like, on the right hand side column, say this is data A, B, C, D, E, and see this is the internal structure, how the data is being stored, right? And on the left hand side, the index, the first column is showing the index, and the second column is showing the data that we have stored in the series. Now, since it is a one dimensional array, right? So only the data is A, B, C, D, E. But when we are talking about the data frames, they are two-dimensional data structures with the labels, and these labels we use in order to find out the data, in order to locate or search the data from that particular two-dimensional array. So you say when we are using the data frames, how does the data looks like? Just a minute. Right, so you can see the data frames, they look like internally how the data is being stored. So in the two-dimensional array also, you can see the data is stored like this. This is one series, each column is basically a series of data. So series of data, series depending upon the number of columns. So here we have the indexes like column index and the row index using, so df is the instance of the data frame. By using that instance or the alias that we use, like import pandas.pd, this is the library that we import, and after that we create an instance of the, I'll show you how we create an instance of the data frame, and that instance df.columns can be used to access the columns of this particular data, and this instance, that is df.index, that can be used to access the rows of that particular data frame, of the data that you have created. So how do we import? So before using, and like we in the last class yesterday we had discussed, how do we import the numpy? So the standard way of importing any of the libraries or packages remains same. So you use import pandas as pd. Pd is basically the alias that we are going to use. Now just to check what is the version of pandas that we are using, that is currently there in the Colab. So we are working, so use the command. See here, you see, I hope you are working along with me. Yes? Can anybody tell me that you are working or just?
Yes, ma'am. Yes, ma'am. We are working along.
Okay, okay. So you just start typing your commands like import pandas as pd, and after that here you, so that you can use as per your wish if you need. Usually we don't make any changes in the indexing. We only work with the data. So this was the feature available. That's why I'm telling. right? Then we have slicing we learned in the list also. So what do we do in the slicing? We try to extract the part of the data. So we have one dimensional array and we want to extract any part of this data. We do that using the slicing. So a is equal to, what is s1? S1 is basically the series that we have created over here. So this is s1, we can use it over there as it is. And after that, what we are writing here, can anybody tell me what is this we have written in the square brackets? Yes, please, we did this. Anyone? Anyone who can tell me what is the meaning of this in the square brackets? Yes, I'm waiting. We did this. Okay, Poonam Garg has said index from 0 to 2. Okay, so what it will do basically? Answer is correct. So it is referring to indexing from 0 to 2. So this will extract the data related to this index that has been specified, right? So this will extract the data from index 0 to 2. So this is the starting, right? Here we say the positions on the left hand side of the column and the right hand side of the column. On the left hand side it is the starting point, and on the right hand side we are giving the stopping. So the right hand side there is nothing, it will start from the 0 index position, and on the left right hand side it is 3, so it is always the given position minus 1. So it is referring to the position 0, 1 and 2, right? So here it is the position 0, 1 and 2 and the data that has been extracted. So we are just taking a slice of the data, right? So this is how we take out a slice of the data. Then similarly for minus 3, who will tell? What does the minus 3 indicate?
Last three values.
Yes, so the beginning value, so it is the backward indexing. So it is going to give me the last three values, minus 3, minus 2 and minus 1, right? This way. So the last three values were 120, 130 and 140, and these are being printed over here. So it remains same. So the point is that wherever you see something like this, you should be able to understand what will be the output of that. You should be able to interpret this, right? Then appending the data. So when we have multiple series, you want to append the data, you don't have to apply the for loop and just navigate and add the data of one series to the another series. You can just use the append function and you can append the data. So let us say we have two lists. From these two lists, we have created two series, S1 and S2, using the same function, pd.series, pd.series. And then what we are doing, we have appended the data of S1 dot appended the series data of S2 to S1, right, and stored in the S3. So when we print it, we are able to get the output, right? So these are the two series we have created. So here if you make any change, this change will be reflected over there. Let us say it is 14, 25, 42. So here you can say when we make a change in the data, and see this is being, and if I make this change, S2 dot S1, so how the data is appended now, the S1 data will be appended at the end of the S2. So the S2 is the first series and the S1 is the second series. In the previous case it was vice versa. Then if you want to drop any data from this particular series, you just have to pass the index value. So let us say we pass the index value to be 1. So it is from the whole series, it is from the S3, it is deleting that because we have repeated index values. Here you say the index values are repeated, so both are removed, right? If I write index value to be 2, so the data from both the indexes, right? So that particular data which is referring to the particular index, that has been removed from here, right? Then operations in series. So you can do, since this is one dimensional array, so all kinds of operation, whether you want to do the addition of errors, division or multiplication, so all kind of operations can be done using the series, right? So only thing you are just have to call these functions. So s2 dot add s1, so this will add all the data of s1 to s2 and it will simply print it. So you can say what was s1 and s2. These are the two s1 and s2. So the addition of these 10, 25 like this. So here you can see when we do this 10, 25, 37, 48, so it is able to do the addition just by calling a particular function. Then the division. So similarly s2 dot division div function we are calling. So using the div function we are passing the parameter as s1, so s2 will be divided by s1, and since it was the division by 0, it is giving us infinity, right? So we can just do the division of every element of one series by the others, every respective element of the other series, right? So all the corresponding elements are being multiplied and they are added or divided, so we are able to get the division results. Then let us say was okay, if we remove the 0 from there, where is the series? Let us say if I remove this and write 10, right? And now the division, so we shouldn't get the, so answer is 1, right? So corresponding elements are being divided. Similarly we can do the multiplication of the two series, so all the corresponding elements are multiplied. Then along with that, like if you want to find out the various statistics of the data, if you want to know like median, max, min, so you simply, there are predefined functions, you simply have to call these functions and then you are just printing the values. So when we do that in the s3 dot median will give us the median value, max will give us the maximum value, and the min will give us the minimum value, right? So this is how we can apply the various kinds of functions which are there on the 1D array, right? That is on series, and the multiple tasks we can do, all kind of mathematical operations, the numerical operations which are required, and you can also find out the statistics of the data using the various inbuilt functions, right, in a very simple way. Then we move on to the creation of the data frames. Data frames are two-dimensional arrays, right? So this is simply, here you can say how do we do that, how do we use the data frames. So here I have used the numpy array. So see, you have different ways. You can, if you want to just learn, you can create a random data yourself, two-dimensional data you can create, and from this two-dimensional on this two-dimensional data you can apply the various operations and you can see the output. Other ways, basically, so this is for the sake of learning we do. Sometimes we have to apply the algorithms, and then for that we need to generate the random data also for just testing the performance of the algorithm. Or we have the existing data that is available and we want to analyze that particular data. So in that case we may load the data from anywhere. So you can load your data from the Google Drive also, you can load the data from your local drive also, you can load the data directly from the GitHub also, like wherever it is available. You have the API, so that will tell you that how to use. You just have to learn the API or the method or the syntax of incorporating or loading that particular data into your environment from any of the locations from where you want. So what do? We are just, I'm just trying to show you that the initial data has been generated randomly. So using the numpy, so numpy array np dot random. So np is alias from the numpy, and random is a function that is used to create an array of random data. So 6 by 4 is saying 6 rows and 4 columns, right? If I change it, so you can say, let us say first see this thing and then I'll just change the values and you can do that. Let us say if I do it 4 by 3, any two values you can try. right? So here you can say we have generated the random data of the two-dimensional array. So you can create the complete random data, right, as per your choice. And depending on, you can also specify the range, also in which range you want to generate this particular data. These days, for the analysis of the algorithms, even the synthetic data is being generated just to with the different mean and different variance, in order to see how the data performs, right, or sorry, how the algorithm performs, right? So here, and what we have done, so df1 is just a user defined name, pd is the alias from the pandas, data frame. So there, we, when we wanted to create the series, we had written series with the capital letters. For creating the data frame, we have to write the capital D with data, and frame also begins with a capital letter. So that means we are creating a data frame for home, and in the data frame we are loading this random data of two dimensional, because your data frame is a two-dimensional array. So the data we are loading into this two-dimensional array is that has been generated randomly using the numpy functions. And after that, just df1, we know this is how we print the data, right? And then let us say, now if you want to see let us say we just want to see what is the for top 10 rows. See, this is a small data. Let us say you generate the data of, no, I shouldn't do it, but let us see. Let us say, right, so I have created a large amount of data. This is still not large, but I'll say, right? So any amount of data you can create randomly. And now I just want to see the top 5 rows. To what are the top 5 rows of this particular data? So you have to use df.head function and just pass the number of rows you want to see. So it will show you the top 5 rows. So you just change the number and see the top number of rows you want to see at a glance, right? Similarly, if you want to see the bottom part of the data, so there you have to use the tail. Let us say I just want to see the bottom 10 records of this particular data. So this is from 10 to 90, right? So these are the last 10 records that have been shown to me. Okay, then now, since these are the basic things, right, that we can do when we are working with the pandas. So now we will be loading the existing data that we actually do in the real time, right? So what do we do in the real time? We don't generate basically this kind of data. We always work on the real data, and that has been provided to us. So now how to load this particular data? One way is, like here I am using the UCI repository data. That data is available at this particular location, right? So I'll copy this path in the chat box. You can take it so that you don't have to hassle with the path that I'm using. The rest of the things you can write all those commands. Oh, there's a chat box. Oh, sorry. Okay, so you can copy paste and use it, right? So that you, when you are typing, you may not get any error. Okay, so now what we are doing is, so I'm loading the data from this particular repository. Let us see what is there. So when you Google, you will find large amount of data is available, and here you say this is the machine learning database. UCI is one of the open source repositories. So you can, whenever you want to do some kind of analysis, you want to learn anything, you simply have to go to this repository. You just write UCI repository. Here you see these are the all files which are available: wine quality red.csv, wine quality white.csv. So you can download these files into your local system, and then you can just upload these files from your local system also. So you just have to write the 2 lines of code in order to load the data from your local drive, right? I'm just calling this directly from this particular path. It will load that into my environment, and I'll be able to work with this particular file. So here we say this is delimited by the semicolons. So let us say just right. So let us see how this data looks like. Here you can see how the data is delimited by the semicolons. So all the data values for the various columns, they are separated by semicolons, what is being shown over here, right? So that's why we are saying it is a delimiter. Okay. Okay. So df read. So this is just a user defined name. So what is the function that we are using to read the CSV file? Here you say pd.read underscore CSV. So this particular pd is the alias for the pandas library, and read CSV is the function which is used to read the data, the CSV file from here. So now all the data, since you can see this is two-dimensional data in the CSV, the rows and the columns. So all the data is stored in the df from for the red wine data. So from this CSV, the data is stored in the df underscore red, and for the white, another data is stored in the another you can say another variable, right? Two-dimensional array that we are talking about, right? And then the now we want to see the details, like for doing any kind of task, we should first of all understand what kind of data it is. So what are the various column names, like, so that we are able to understand what are we looking for, or which on which columns we want to work on, what are useful to us, right? So we just try to understand the structure of the data. So for understanding the structure of the data, let us say first we are looking at the red wine, the df underscore red dot columns. We want to see what are the columns available in this particular CSV file. So because both are related, both are data sets are related, so they have the same column names, right? Fixed acidity, volatile citric acid, residual sugar, chlorides. So all the ingredients, they are written, and then it is the quality parameter that has been assigned at the end, right? So now, so similarly, like df underscore red, oh sorry, we have not executed this, that's why it's giving us this error. Are you able to execute this? Yes, please. Just write in the chat box whether you are able to upload your data or not. Write in the chat box whether you are able to work or not. How many people have done it? How many of you have done it? Only 2? Anybody else? All others are doing? Okay. So I expect all are doing it at their own pace, right? So let us move ahead. Right. Now, after looking at the various columns, the schema of the data, right? So we move on to, we want to see the data types of the data. So what we have? D types, right? So we just call D types, and we are able to see what is the data type of each product. See, why do we need to understand the data types? Because when we are working with the data, you will see that we have to prepare the data for the analysis. So for the data preparation, what we have to do, we have to work with them, we have to find out if there is any missing value in the data, or like there are certain null values, right? What is the sparsity level of the data? That if the data is highly sparse, we have to understand how to remove that sparsity, right? So we may, sometimes we remove the, if the data is, let us say if there is one column which is highly sparse, so there are hardly any values in this particular column, so we try to remove that particular column. Then there are other columns where some values are missing, the major part of the data is there, then we fill up those values. So we try to find out all those information, see the different ways to pre-process that particular data. So if we have to fill out the missing values, and we should know if the data type of this particular data is numeric or categorical. So if it is numeric, sometimes what we do, we fill up the mean value of the data in the cells where the data values are missing, right? In case of yes, please. And in case of let us say when we are working with the categorical data, in that case what do? We sometimes we take out the most common value and fill the columns where cells wherever the data is missing that particular column value. So we have a long list of you can say methods which can be used to work with the missing values, right? So now we have another, after looking at the data types, what are we just trying to see? Again, we have an ILOC function. So for the slicing, so there, like in the series also we were doing the slicing, so here also we have one function for the slicing in the your data frames, that is called as ILOC. Using this ILSC function, we can see the slice of the data. So here we can see the slice of, using the slice, we just are looking at 100 to 110. So let us say now we want to look at the 110 to 120. So it is showing us another slice of the data, right? So we can see the data slices as per our requirement. Then we want to know the statistics of the data. Statistics of the data tells us what is the distribution of the data. So because the people who do the statistical analysis, they require all this information. So the only you don't need to compute all the statistical parameters separately. You just have to call one function that is called as describe, and it will give you all the statistics of this particular data, right? So here you can say this is telling us the count, that means how many records in this particular data. So we are working on the red wine data. In this particular data we have 1599 records, and the mean value of the column, right? So here you say we have all the records because it is a complete one data sets, so it is same, the number of count is same for all the column values. But here you say for the fixed acidity the mean value is 8.3, for standard deviation of the data is 1.7, minimum value in this particular column is 4.6, the 25th percentile 7.1, then 50% percentile, 75 percentile, and then the what is the maximum value in this part. So now we know what are the statistics for a particular column, right? So the pH values, sulfates, alcohol, quality. So everywhere we know we can see what are the statistics of this particular data using just one function that is called as describe, right? Now we want to get more information about this particular data, right? So what is the more information, like the data types. If there is anything null, so we just want to have a count of that. So complete information. So using the D types, we were only able to get the information about the data types, but here we are getting more information. What is the range index? That is 159 entries, 0 to 1598. This is the index range. Data columns, there are 12 columns in this particular data, so these are named as this. Then nonal entries, so all the count, so what we have, right? Their data types. Then you see the data types, there are 11 columns whose data type is float, and there is one column whose data type is int. Then how much memory it is using, so the memory usage is also shown, that is only 150 kb of memory is being used by this particular data, right? So we are able to get the complete information using just by calling the info function. Then let us say we want to analyze this particular data. So we want to see the, with the help of, we want to see, visualization is considered to be the best way in order to understand the data in an easy way rather than using these numbers. So although these numbers are very important, but sometimes the visualization is the, you can say it is the most preferred way to understand the data, right? So there are multiple packages, like the most common package that is used for the visualization is the matplotlib. Matplotlib is one of the oldest package and is having the core package for creating the visualizations for all the charts, right? So this library, as you know, that once something has been created, people try to just create the advanced thing over on top of that for the more you can say more with more of formatting, with more of features, right? Some additions are being created and a new package has been created. So this Seaborn package is basically developed, it at the core it uses a matplot library only, right? But it provides some additional features that you will come to know when you start using the packages. You will see the difference, that when you are working with a matplotlib, this is the basic thing that is available, all the basic features are available. But if you want to go for some like beautification of your graphs or of your charts, in that case you import the Seaborn package, right? So you can say it is used for creating more attractive and informative statistical graphics. So while it is a different package, but it can be used to develop the attractive effectiveness of the matplotlib graphics also, because it is built on top of the matplotlib only. It is using the core API of matplot library itself. So how do we use the seaborn package for creating the visualizations, for creating the charts? Import seaborn as SNS is just nothing, an alias. Then sns.set. So we are creating a figures. So the figure size is 8 by 8. So this is creating the dimensions. So these are the dimensions of the figure. So let us say I created this, and then we are creating a count plot for the quality. The quality is one of the columns, right? So here you can say we are creating a count plot. It is telling with 3, 4, 5, 6, 7, 8. So these are the quality parameters, and there are 3 records. Here you can say there are 3 records with the quality parameter 3, 4 records, right? Sorry, you can say not the 3 is not the count. So with the quality parameter 3, the number of records is shown on the count, is shown on the vertical axis, and the horizontal axis is showing the quality. So here you can say with the quality parameter 5, we have the maximum records in this particular data, nearly 700. Similarly, for the quality parameter 6, we have more than 600 but less than the 5. And similarly, around 200 records we have for the quality parameter 7. For 3, 4 and 8 quality parameters, we have less amount of data. So when we do this, simply we are able to get this particular data. So now if you have wished, so you can look at the other features also. So by default we have created, it is creating the plot with these colors, but you have the option, you can change the colors also. So many other things are there which you can change. You can create the 3D graphics also, like you do in the your Excel sheets. You plot the charts and you have different choices that you can create a 2D figure, 3D figure, feel like that. So all such things are also available here in the Python, in these libraries also. You just have to learn to use them. Let us say if I do, what happens if I use this 10 by 8? So just see the difference, how the size is changing, right? So it has increased. Okay, let me increase it to 20. You can see the size of this. So the it is increasing the size horizontally. It has increased. Let us say if I make it again 8, and if I do it, let us say it is 15. So how the size of this figure is changing. So now it is increased vertically, right? So you can say this was x-axis, this is y-axis. We are increasing the size along the x-axis and the y-axis. Accordingly, the size of the figure is shown over here. Okay. So next we have the pair plots. So using this library, we want to analyze the data based on the variables, like 2 variables at a time. Let us say you want to see the fixed acidity and volatile acidity. What kind of relation is there between these 2 attributes? Or you can say between the volatile acidity and citric acid, what kind of relationship is there between these 2 attributes? So when we create the pair plots, basically, so these pair plots, they give us the analysis. They help us in analyzing the data between all the pairs of this, right? So we have 12 attributes, and all these 12 attributes, these graphs, so you can say how many graphs are plotted? 12 by 12, right? So you can count. So these are 12 by 12. So each and every attribute. So here you can say in this row, the fixed acidity is compared, the graph is created, this plot is created between the fixed acidity and fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur, total sulfur, density, pH, right? So this column, this row, this is representing, this complete row is representing the relationship between relationship of fixed acidity variable or attribute with all the other attributes, right? So whether that is increasing or decreasing, right? What kind of behavior it is, right? So when you analyze the data, so you can see the relationship between them, right? Then heat map. So we use the heat map. So how do we create? Simply, see, for all kind of plots, you just have the functions, right? You just have to see the function names. So this heat map here is one function we are passing the correlation. So basically it again, so it is showing the correlation between the all the attributes which are there. So correlation of fixed acidity with itself, it is highly positive, so 1. So volatile acidity and fixed acidity, they have a negative relationship, right? So negative correlation. So citric acid and fixed acidity, they have also, no, they have positive correlation, right? Then but the correlation here, in case the correlation value is high, but residual sugar and fixed acidity, the correlation value is low, right? So you can see that when these colors have been chosen, these are also indicating the higher side. So you can say wherever there are negative values or higher values, they are being shown in the dark colors, right? So this heat map is basically showing the heat, right? So from the colors itself you can make out. So you so here also again you can choose the colors also. Here you can see the you can see the annotations, we are writing true, so it is showing the annotations. The line width is true, so again, so everything you can just try to make a change and see the difference, right? So these colors, this basically these are also reflecting the kind of correlation that is there between the various attributes. Then SNS dot distribution plot. So distribution plot again, so basically it is showing a warning because this is this is deprecated. So you can find out what is the new way to do that. So even see, warning means you can execute, but the just a suggestion that you should look forward to the updated version of this, right? So here you can say the distribution of the data, the bins are being created. So in each bin, how many records are there based on this, right? So here you can say we are working on the distribution of the data for the alcohol attribute, right? For the alcohol attribute we are just looking at, so here this is the alcohol attribute, and we are just looking at the various bins that have been created. So all the data is distributed like this based on their density, right? So then what is the skew? So what is skew? Yes, anybody can tell me what do you mean by skew? Yes, please. Can anybody tell me what is skew? SKEW. Anyone? Yes, Q. See here when we are talking about the data, so we are saying that the symmetry of the data. Yes, we are trying to discuss about the symmetry of the data, right? So whether the data is one direction, whether the data is properly distributed, if whether the data is having the normal distribution or it is a skewed data. So it may be the meaning when we are talking about the skewed data, that means whether it may be, let us say we have different kinds of data that is there. If the more of the number of records are there with the negative data and less number of records are there for the positive data, so when we apply some algorithm and try to analyze that particular data, so the output will, the predictions that we do, they will also be negatively skewed more or less, right? Because majority of the data that we have in our records, that is negative data. Similarly, if we have the more amount of data positively skewed, so our you can say the predictions, they will be more oriented towards the positive results. So we say that whenever we have a data, so we should check out if the distribution of the data should be normal distribution. We should not have the skewed data because that affects the results. So here we are testing. So here you can say when we compute the alcohol, so we are computing the records of the alcohol, and then we check out the skewness of this particular data. The value is 0.86, so it is, you can say, positively skewed data, right? Then we compute the box plots, right? So NSS dot box plot. So box plot are created between the two parameters. Along the x-axis we have the quality, along the y you can say this are you can say this these box plots, they are able, using these box plots we are able to find the statistics of the data, right? So that the lower part, it is the 25% you can say this is the minimum value, this is the mean value, and this is the maximum value. And here you can see these, all these are the outlier values that we have. And 3, 4, 5, 6, 7, these are the quality values, right? So we, how much data is there related to the algorithm, the number of records that we have. So there are you can say with the quality parameter 3, so what is the distribution of that particular data? So using this box plot we can make it out. Similarly for the quality parameter 4, so what is the distribution, the number of records that we have with the quality parameter 4 in this particular data, we can see the data distribution of this, right? So from here we can see the distribution of the data based on the quality parameters also, right? They are basically the classes, right? So when we do the classification type of task, like in the machine learning, we are most of the time, the two common tasks that we perform is, one is classification and another is clustering. So in the classification, let us say you want to find out, like in your data, whether the picture that has been shown, that is the image of a car, truck, or bike, or you can say aeroplane. So this is categorical data. So here also again this quality is indicated in terms of quality level is 3, quality level is 4, 5, 6, 7 or 8. So these are the classes of the quality, right? So this is how the data is being interpreted. Then we have another plot that is called as joint plot, where we are multiple plots can be combined together in order to analyze the data. So how the data is being distributed. So now let us understand the correlation. So what is correlation? Anybody? What is correlation? Can anybody tell me what is correlation? What is correlation? Correlation is the same thing that we have already discussed, relationship between the two variables, right? So here we say the relationship between two variables, right? We are trying to understand. So using this correlation, whether they are like how they are connected with each other, like what will happen if we change the one is increasing along with the other one, whether it is if one increases the other one is decreasing. So what kind of, whether they are directly proportional, they are inversely proportional, or there is no relationship between, both are independent of each other, right? So or that means they are positively correlated or negatively correlated, right? So we are using, so there are different ways to compute the correlation. Here we are using the most common one, the basic one, the basic type of correlation that we find is the Pearson correlation. So what do we do? So again, SciPy is one more package or library that is having the statistical, you can say the all the statistical packages, sub packages are stored in the SciPy. From there we import the Pearson library. So and what do? We are just creating one function, def is used to create the definition of a function, defining a function. The name of that function that we have defined is get correlation. So get correlation between whom? Between the two columns, column 1, column 2, right? And we are passing df as one parameter. So what is this? So what we have passed on the Pearson correlation, then p value, right? So and then Pearson what between the column 1 and column 2. So when we are passing this column 1 and column 2, right? So we are able to establish the correlation between the two, right? So now we have just we just created a function, we execute this, and after that we call this function. When we are calling this function, here you see they were asking column 1 and column 2. So we have written the names of the two columns. Df is referring to the what kind of data you want to apply this on the df red wine data, the two your df object that we have passed. So df is what? Data frame, right? So here when we are executing it, we want to change, let us say what is the other name for, let us say we want to see the correlation between chlorides, chlorides, right? So we are able to see what is the correlation between the chlorides and the pH, right? So this is how we compute the correlation. And this correlation What does the p value indicate? So this p value indicates with what confidence, with what probability we can say that the correlation between chloride and pH is this one. Probability of, so this is basically referring to the you can say the how truth is this hypothesis. So the probability of occurrence by chance, right? So this is how we interpret these. So basically this p value is telling what is the chance that this particular value may not be true. So this is you can say highly you can say very low probability that this is not true, right? So there are more chances that this correlation is correct. Then white wine analysis similarly we are doing. So we are just calling the describe function in order to understand the data, right? So finding the count. So in this particular wine data, what we have, the 4,898 records we have. Mean value, standard deviation, minimum value, 25 percentile data, 50 percentile, 75 percentile, and the max value of this particular column. Similarly, we have all these values for all the columns, right? So you can say we have the easy ways to analyze the data, to understand the statistics of the data when we are working with the data frames, right? So we want to compute the mean or the white mean and the red mean. So here you can say print for the quality, right? So here we have computed the mean value of the quality for the your white wine data and the mean value of the quality parameter for this. So here you can say the both the values are around 5.8 and 5.8. So that means the similar kind of distribution of data is there in both the data sets. Now here you see D is equal to, so what do we write in the curly brackets? Can you tell me what is this data structure? D is equal to curly bracket, color, colon, red wine. Can anybody tell me what is this data structure in the first row? Yes, Shalini Singh is right. This is a dictionary because the data is there in the curly brackets. So from here, like this is how you have to understand and interpret. Like here, the data is stored in the form of curly brackets, and here, first thing, the curly brackets. Second thing, it is in the form of key value pairs. Color is the key, and these are the values red and white. Mean quality is the key, and the values over here that we have computed from here, right? So after that we are just storing this data in the form. So here you can see now from the dictionary we are creating a 2D array, right? So previously in the beginning we created a list, right? From we created a data frame from the you can say from the list, from the data that we had from the CSV file. This is from the dictionary, right? So for the different kind of task you may use the different data structures, right? So and we just want to print that in the form of a data frame. Here you can see the red wine, so the color is red, the mean quality is this, the color is white, and the mean quality is this. So let us say we want to add one more attribute. Since see what why we are doing is, let us say we had two different data sets that we have loaded. One is the wine data set, another we have the red wine data set. Now we are looking at the distribution of the data. We computed the mean quality of the data because the quality parameter is the last column, and that is important to find out what quality of what was the quality of a particular sample that we have tested in this particular data. Now after computing the mean, now we are looking forward, since we are going to combine. So if we combine, if we don't, after that it will not be easy for us, we won't be able to segregate that, right? So because we don't have any indication which one is the tuple that we have taken from the red wine data, and which one is a tuple that we have taken from the white wine data. So what do? We just can you just give me a minute?
क्या मैम अनम्यूट कर लीजिए.
Okay, sorry. Okay, so we had I've just executed these, and now what we are doing is, so here we have done the added one more category, one more column into the existing data in order to just indicate that this all these, one data that we have picked from the white wine and another data we have picked from the red wine. And after that we are just trying to find out what are the unique values repeated, and we are just printing what are the, so what we have done, sorted df red quality dot unique. So what we are doing is, from the df we are you can say data frame, we are taking up the quality column, and then from the quality column we are just want to print the unique values. So they are 3 4 5 6 7 8 here also, and in the white wine also we have these parameters. So here we have one more additional quality parameter, that is 9, that was not there in the red wine. So that may be for the red wine there was no sample that was received with this particular quality, right? So after that what we are doing is, since these are the numerical values that we have, we are just converting these numerical values of the quality column into the you can say this is the continuous data, we are converting that into the discrete data, right? So we are converting all these values into three you can say we are performing the discretization into low, medium and high, right? So what we are doing, df red quality label, right? So what is that quality label? Red quality dot apply. So we are creating another label where we are going to store this value. So the quality label red quality dot apply, so we just create one lambda function which will be mapping the values. So low, so it will assign the low value if value is less than equal to 5. So less than equal to 5, all these values 3 4 5, they will be replaced by low, else medium, right? And if the values are less than equal to 7, else it is, so that means between the 5 and 7, right, it is medium, and else it is high, right? So that means 8 and 9, they will be assigned the high values. So this task we have done it for the red wine. So we, what do we do? So we have the quality label is equal to pd dot categorical. Now we have created the categorical label, df red quality label, categories are low, medium and high. Similarly for this we have just done the same procedure and assigned the values. So replacing all the records with all these numeric values, the continuous data into the categorical data, from these values to the low, medium and high, because it becomes easy for us to analyze the data when we are discretizing that particular data, right? So after that, df white quality label we are checking dot value underscore counts. Similarly we are computing the you can see we want to see the value of counts for all the labels that we have. So we have medium records, you can say on the number of records with a medium value 3078, low 1640, high 180, right? And similarly, so this is for the white and second one is for the red, right? So let me execute this. Then what we are doing here, you see we are just concatenation of the two data sets of via two data frames. So we loaded the data into data frames, and after that we have just concatenated that particular data, and that is stored in the new data frame that is known as df underscore wines. The old data was there in the df underscore red, df underscore white, and df underscore wines is equal to wines dot sample. What we have done is, using that using this function, what we are doing, we are rather than just taking all the rows, upper rows to be the red and the lower rows to be white, belonging to the white. So we have just shuffled the whole of the data. Shuffling is required when we have to analyze the data, because when we apply the machine learning algorithms, we divide the whole data into training and test data, and for the division of the training and test data we should have the sample random samples. So let us say if you're working with the let us say you divide the data into training, 80% of the data you take it for the training, and the 20% of the data you take it for the test. And let us say by chance that the top 80% rows you have taken it for the training, and the rest 20% rows you have taken it for the testing data. So if we have just appended the data at the end when we do the concatenation, so the all the data samples that have you are using for the testing purpose, they will be belonging to one category, that is the wide data set in this particular case. If you have done the concatenation other way, it will be only belonging to one category of wines, either it is red or it is white. So it is recommended that you should take this random sample in order to see the efficiency of the performance of the algorithm properly. So here what we are doing, we are just printing the wine data set or top 10 records, right, head. So here you can see what we have. So now we have not deleted the quality, so the quality column as it is, we have added two categories. One is white category that we had done, that when we added in the beginning, that we were adding this one where it is, yes, along with quality wine category. Here you can see this attribute we had added, and then to this category we had assigned the labels, quality labels, pd dot categorical quality labels, and then right, so categories we have assigned. So wine category is red or white, and correspondingly the labels are high, medium, and low. So this is the task that we have done. So now our data looks more beautiful because we know the category of the wine also, and we also have the quality labels for this, rather than, so along with that we have not lost this information. And if now, since the wine category is already known to us, from if we want to segregate the data again using this particular label, we can again segregate the data as per our requirement. Right, so this is just another way to look at the data. Like we have taken the sub attributes, alcohol, density, pH, and quality. We just want to look at these. We want to you can say the combine the data, concatenate the data based on these attributes. So the low, medium, and high, so the label is low wherever the attribute level is low. We just want to have information. So here you can say we are calling the describe. We just want to understand for the low quality wines, for the medium quality wines, or for the high quality wines, what are the statistics, what all statistics, the alcohol, the density, and the pH. So let us say, because I'm not the domain expert, I'm not aware about these wine qualities and all. So maybe let us say the density and the pH values, they play a very important role for these alcohols. What is the alcohol level in this particular low quality wines, right? So from here we can see in the low quality wines, what is the alcohol level, what is the mean alcohol level, what is the standard deviation, what is the minimum value, and similarly what is their density and what is their pH levels. And for the medium quality wines, what are their you can see what are the quality levels for these. Here you can see the quality levels for these the quality levels for this is 6 and 7. We already knew because we have categorized the data that way. And the alcohol levels, what is in the medium quality wines, the alcohol level is higher as compared to the low quality. Similarly for the high quality wines, the alcohol levels are higher as compared to the low and medium quality. So this is how we can analyze the data as per our requirements, right? So we from this we can try to understand and interpret the data based on the various parameters which are of interest to us. Now again, so using the matplotlib, what we are doing is we are trying to understand the data again. So what we have done is, so we are again doing that kind of analysis using the, so we have different ways to analyze the data. So here you can say here we are trying to create a histogram. So histograms where we are creating the bins. So number of bins that have been created is 15. That means we are dividing all the records of the data based on these parameters, the attributes, that is fixed acidity, right? This is based on the volatile acidity, this is based on the citric acid, right? So all the set of records, they have been divided into 15 bins, right? So the 15 bins, in that case, so how much data is there in each bin, right? So and all these are the indicators, like what is the line weight, the x label size is 10, then y label size is 10. So you can just change the values and just see the, so here again it is a figure size that, and you can say if you want to make any change, you can just try out the various parameters, make the changes, and the, let us say, dark magenta, you change this color and see how it is looking. If we remove the labels, then what is the effect of the size on these labels? So just play with this. So you have to learn by doing, right? Then, oh, this left. Df underscore vines. Okay, something left to be executed. Oh, we have not executed this. That's why it is not able to read the df underscore vines. Then, okay. Okay, so we are able to, and from these histograms we can get the information whatever we want. Then again we are looking at all the parameters. So here now, since we have analyzed the data, we have seen, we have combined the data, we have seen the different methods to understand the data, right? All the wine qualities, right? How do we you can say, if we want to categorize the data, we have the continuous data, we can convert this continuous data into the categorical data, right? How we can add the labels, right? How we can let us say add the columns to the data frames. Then we can convert the continuous data into categorical and assign them the categories, right? We can understand, using the describe function, we can understand the various statistics which are there in the data, right? Count, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, like that, right? So we have understood the correlation between the matrices, right? So what is the relationship between the variables, what are the different ways to visualize this particular data, right? So many things are there that we can do when we are analyzing the data, right? So we have different methods to understand this particular data, right? Then after doing this statistical analysis, see this particular part that we have done till now, this is called as exploratory data analysis. That is the basic data kind of data analysis that we can do, like if we have no knowledge of any of the algorithms, right? So this is called as EDA, that is exploratory data analysis. So we are just, what we have done, we have just explored the data, understand the statistics of the data, we are just creating the plots, we are trying to find out the relationships between all the variables which are there, and then just try to understand what is there in the data, right? So some descriptive analytics that we are doing, how we are just understanding what is there in the data, right? Then let us say, see, we have the sklearn library. So if we want to apply the machine learning algorithms, right? So for that sake, you need to understand first what are these machine learning algorithms. As I've told you, there are two categories of machine learning algorithms. One category is called as the supervised learning, another category is called as the unsupervised learning algorithms. In the supervised learning algorithms, they are basically the classification algorithms, where we are trying to classify. So here in this data that what we have done is, now we have classified, we have converted this data into the classification data, and the classification label is the quality label. So what we are saying, if we talk about the tuple number 3, right? So this particular tuple, this belongs to, so the what is the class of this particular tuple? That is medium. The class of the second tuple is low. The class of the last tuple is medium. So this data is being classified. So whenever something new comes up, we can use this particular data. What we can do is, we can divide this particular data, the complete data, right, into the, so let us see what how many records are there for this particular data. Can anybody tell me? How many records are there in this particular data? Or how can I find out the number of records in this particular data? How do I find out the number of records in this particular data? df underscore vines dot info. Okay, so let us see how many records are there. Here we have 6,497 rows and 14 columns. Because earlier there were 12 columns, we have created two more columns, so it is giving us 14 columns, right? So other ways we can just find out the shape. So here this is giving us where is that, df underscore vines dot shape. So this will give me the dimensions of this particular data. So it is telling me there are 6,497 rows and 14 columns, right? So what do we do when we have to apply the machine learning algorithms? The complete data is divided into two parts. Why do we divide that into two parts? Because we have to test the accuracy of the model. Let us say you apply one algorithm. So these are the different algorithms like logistic regression, linear support vector, then k nearest neighbor, then random forest classifier, gradient boosting classifier, ADA boost classifier, decision tree classifier, Gaussian neighbors. These are the various machine learning algorithms which are used to develop the classification model, right? And these are all available in the sklearn library. So this is the library which provides you all the inbuilt functions, or you can say the implementation of all the machine learning algorithms, right? So what we are doing is we are just trying to find out, like, applying all these multiple algorithms, and then we want to see, right, what do we want to see? We want to see what is the performance of all these algorithms, which algorithm will give us the better accuracy of classification. Whenever the new data comes up, let us say this was the existing data, now you create a program, you create a small software or your web application, and using the Python, and then you say that you give me all these parameter values, you give me the you can say, let us say you tell me the fixed acidity, volatile, all these parameter values you input, take it from the user, and you can tell what is the quality of this particular wine, right? So you want to make a prediction for the wine, for the new sample of the wine, and then you have to tell with how much accuracy, right? So what is the performance, what is the accuracy of your model? It always gives 70% of the results that are given by your model are correct, or 80% of the results which are predicted by your model, they are correct, like that. Like when we are see in the last 2 years during the pandemic, so we had been going through the testing of the COVID. So we were saying that I had COVID, but that it was showing I don't have COVID. So there are false predictions also, there are true predictions, there are false positives, right? False negatives, true positives, and true negatives. That way we have to understand the whenever the predictions are being made. So true positive and true negative, that means something was positive and you also predicted positive, something was negative and you also predicted negative. Then false positive, no false positive means if somebody was not suffering from the disease, but you said the person is suffering from the disease. Otherwise, false negative is somebody was not suffering from the disease and you said it is suffering from the the person was not suffering from the disease and you said the person is suffering from the disease. So you have to understand the predictions which are being made. So here you say we are, then what we are doing is, first of all, we are just importing the packages for the implementation of all these algorithms. Then we are, for the model selection, what we are doing is import train, test, split, and cross validate. So train, test, split, that is using this functions, what we are doing is we are going to convert the data into two parts, training data and the testing data ratio. So based on that, we are going to apply the algorithms and develop the model, and then after that we are going to check the accuracy of the model on the basis of the accuracy score, the precision score, recall score, and the F1 score. So these are the basic evaluation parameters which we use when we are working with the classification models. And here we do pre-processing, min-max scaler, standard scaler, and label encoders. We use these are the different ways to pre-process the data, so that there is, whenever we are analyzing data, this is called as feature engineering. We are just scaling the data, right? Normalization of the data we do using the various methods. So that is what is being done over here. So what we are doing, label quality, so we are converting the label to label encoder method, and then we see like quality labels. Now they have been converted. So the label quality dot fit transformed DF wines label. So what we are doing is, when we see the data, what was the quality label earlier? Let us say quality label was high, low, medium, right? And when we do the label encoding, we just have converted, because we had only three labels, medium, low and high, so we have converted into the numeric values of 0, 1 and 2, right? So what do we do? First we execute this, we import all the libraries for applying the machine learning algorithms. Then we are also importing these packages. Then we are just doing the label encoding. This is just to show that how do we do that. And when we see the output, we should be able to see the effects. So we are able to see that the quality labels have been converted, right? So similarly, so this is your choice basically. Sometimes we want the numeric values, sometimes we want the categorical values. So this was just to let you know how we can do that. Now here you see X train, X test, Y train and Y. So all the X train means all the training data, right? So that means X train, X test is from the initial data, right? All the number of records that we have, right? So all the number of records that we have, 6,000 something we have records, they are into this particular data. And how this division will take place, df wines dot. So what we are doing in this particular data, we are dropping two columns. One is quality and another is wine category, because we don't require for this particular data analysis along access1. So the complete columns will be deleted. Then df wines dot quality label, that will be the y-axis, right? So that is the label that we require, right? And test size is 30. So that means 30% of this data will be used for the testing and 70% of this data will be used for developing the models. So now what we have done is models is equal to logistics. So here we see, you need not do this particular task this way. You can simply use one model. So I'm just going to take up all the models. So I have put them together. So here you can see I have created a list, right? So this is a list of all the models: logistic regression, linear, support vector kernels, then k-nearest, random forest, decision tree, gradient boosting, Gaussian aegis. And after that, what I'm doing is, 1 minute. So I'm just going to say this is, say all the values are given in the codes, so they are going to be printed as it is. And after that, I'm creating one accuracy list, empty list, and one accuracy evaluation accuracy, this thing in the curly brackets, we are creating one empty dictionary, so for storing the data. For model, I'm just, because I have to execute all the models on this particular data, so I'm using a for loop for model in range length models. So this here we had created, this is the purpose of creating this particular list of all the models. So it will navigate through this, and classification underscore model is equal to models dot model classification model. It will pick one by one each model, then it will fit. When this is called, this fit function is basically called in order to do the training of the model. So here xtrain records all the tuples, y-train records all the labels corresponding to all these tuples. So what is y? So here you can say from fixed acidity till alcohol, all these will be there in the x-train. Out of that, so all the labels with 70% of the data only, and this y-train will have only the quality label with 70%. So corresponding labels will be there, right? And after that, so when we call this function, the actual model is being created. And after that, for making the predictions, we call the predict. On all the predictions are made on the test data set. And here you see, how do we compute the accuracy? We see we are making the predictions for all the labels from the test data set, and after that we compute compare all the labels with the actual labels. If they are same, we increase the accuracy score. Let us say we had 20 records. Out of that, we are able to predict the correct labels for the 18 of them, right? So we are able to get the 90% of accuracy. So the same is being done over here. So we are just doing that accuracy dot append, and we are making the prediction for each and every sample that was there in the test data set, and we are just computing the accuracy score and appending it. After that, simple, evaluate accuracy. So here you can say we are just associating, creating a dictionary. This is the key, the modeling algorithm corresponding to its name, and then the what is the accuracy score for that, and then we just print it. So here when we execute this, since we have large number of algorithms, so it is creating the model. So here you can see, right? So here you have modeling algorithm, the logistic regression, linear regression, all these are there, and corresponding to that their accuracy scores are: for logistic regression the accuracy score is 0.96, for the linear SVM it is 0.97, for the RBF it is 60% of accuracy, for the k nearest neighbor it is 69, and for random decision tree gradient and Gauss 100% of the accuracy is being shown over here. And these results may vary if we change just this value, right? So whenever you have it, there is a change in the, let us say I just use percent of the data for the training and 50% of the data for the testing, and then again we'll have to re-execute for creation of the model, and let us see what is the output, right? So there is not much change in the accuracy of this course, because it all depends upon the data, the kind of data you have. Similarly, now if you want to plot this data, so you can say if you want to just the formatting of the data, you want to make it more presentable, here you can say we have made the data more presentable by plot. You can say we have sorted all the data and printed it in their ascending order, right? Sorry, descending order. So random classifier, decision tree, gradient boost, neighbors, they have the 100% of accuracy, and after that they are just printed in the decreasing order of their accuracy. And now the same data we can plot, right? So from this particular table here you can see now we are able to plot this. We have created the bar plots. Wait, this table, this was not executed, so that's why it is giving error. It was not able to recognize this, so we have just plotted. So you can show, see, looking at this particular data, so this looks better because here we can easily find out, right? We don't have to read the numbers. We can see all these 4 algorithms, they have same performance, then the next 2 have almost similar performance, and the worst performance is being shown by k nearest neighbors and RBF SVM for this particular data set. So when we apply all these machine learning algorithms, so along with this, so we are done for the task today. So now you know how to analyze the data using, you can create the various kinds of plots, you can do the exploratory data analysis, as well as you can apply the various machine learning algorithms for analyzing the data. So that's all for the today. So this is done from my side. If you have any queries, you can ask. Any queries?
Then, yes. You can also ask the question.
Okay, I'll upload the in the classroom itself.
Then we can proceed for the validity session, ma'am.
Yes, sir.
Sunil?
Yes, sir. Okay. I'm taking the charge. Okay. Hold on, sir. Harshita, are you here?
Yes, sir. Yes, sir. I'm here.
Okay, you please start.
We have come to an end of this workshop today. I would like to thank everyone for attending the sessions. A heartfelt thanks to Dr. Shikha for gracing the sessions with her presence and for patiently responding to all our queries. It was indeed an insightful experience. I would also like to extend my heartfelt gratitude to our beloved Principal Sir, Professor Narendra Singh, Professor P.K. Sisodia, co-coordinator, our college administration, for having us provided support and this opportunity. This was conducted under the aegis of DBT-STAR College scheme, which was initiated by the Department of Biotechnology, Government of India, in 2008 to support colleges and university departments offering undergraduate education to improvise and strengthen both academic and physical infrastructure. It strives to enhance the quality of learning and teaching process through hands-on exposure for experimental work to various research laboratories. Under the aegis of DBT-STAR College scheme, we conduct various seminars and hand-on workshops like Workshop for Art and numerous outreach programs as well for the students of the science department. Now, I would like to invite various participants to share their experience and feedback with us. First one is Dr. Ritu, Associate Professor, Department of Mathematics, Janki Devi Memorial College, University of Delhi. Dr. Ritu.
Ritu ma'am.
Yeah. Can I start?
Yes.
Am I audible?
Yes ma'am.
Yes, ma'am.
Am I audible?
Yes ma'am. You are
Yes, ma'am.
Yes.
So first of all, I would like to congratulate the organizing team of Zakir Husain Delhi College for the successful completion of 5-day workshop. Introduction to Python for meta-analysis of data. Thanks for giving us an opportunity to attend the workshop. The topic for the workshop is very relevant as we need to deal with different types of data for our research projects. It's all the more important as the language has been introduced in the skill enhancement courses under the new education policy in University of Delhi. So this is all the more important to attend such workshops. My heartfelt thanks and congratulations to resource person Dr. Shikha Mehta for conducting this workshop so efficiently and so smoothly. Dr. Shikha has introduced us the highly useful coding language Python. I must say she's just brilliant and expert in her field. She introduced us to the language and taught us the syntax of the language in a way that we could understand everything so easily. She's so calm and composed, and throughout the session, she listened to our problems with a lot of patience and cleared all our queries. The sessions were very interactive indeed. She was constantly encouraging her students to practice all along and was solving their problems without any delay. I personally have learned a lot from the workshop. I can say the same for other participants also. I'm sure the workshop will be beneficial for all of us. Once again, thank you so much for this workshop.
Anika from Mathematics Department, Zakir Husain Delhi College.
Good afternoon, everyone. My name is Anika Mittal, and I'm a third year student at Zakir Husain Delhi College. First of all, I'd like to thank Dr. Shikha Mehta for taking out time for us and teaching us Python. And it was a lovely workshop. And being from a humanities background, I thought I would not be able to understand Python as much. But you've helped us all along. You've taken up all our doubts, and the sessions are very interactive. And I'm really glad that I joined this workshop. Thank you so much.
Shruti Narang from Department of Mathematics, Zakir Husain Delhi College. Shruti Narang.
Shruti Narang. Shruti is there. Shruti.
So she's writing a message. She's not able to unmute. She's trying out. She's writing in the chat box that she's not able to unmute.
I think Dheeraj, can we ask for if all the participants would switch on their cameras? Will it affect the speed for just a last of the proceedings?
Yeah, we can have a group photographs too.
Yeah. That is what.
Hello. May I?
Yeah,
Yeah.
Shruti.
Hi, good afternoon, everyone. I'm Shruti Narang, and I'm a third year student in Zakir Husain Delhi College. I would like to extend my gratitude to Shikha ma'am for giving us her time and for this wonderful workshop, and also to the convener Dheeraj sir and respected organizers for organizing the workshop and making it a great success. This 5-day workshop has been really insightful, and personally, as a beginner, it has helped me to understand Python and develop my interest to learn further in it. And because similar skills like this are in demand and will create a niche in our profile, the workshop was very systematically organized. The modules were explained using effective examples. I thank everyone for taking out this effort for us young students who will be going into the job market in the near future. Thank you.
Dr. Pravesh, Associate Professor, Department of Physics, RN College, Hajipur.
Electronics. She's in electronics.
Okay, sorry, sir.
Parvesh, are you there?
Dr. Parvez.
जी यस सर
Yes.
अच्छा, ये
please.
जी
Okay, I thought Parvesh, it's Mr. Parvesh. Okay, anyway, so he may be in Department of
थैंक यू
Physics.
सर थैंक यू आई एम मोहम्मद नैयर परवेज डिपार्टमेंट ऑफ फिजिक्स आरएन कॉलेज हाजीपुर थैंक यू टू शिखा मैम एंड डॉक्टर पीके सिसोदिया very interesting workshop was carried on. Thank you, ma'am. Thank you, sir. Thank you.
Mr.
Anyone
Himanshu
else
Bhatt.
want to express their? Okay.
Mr. Himanshu Bhatt, Research Scholar, Department of Mathematics, University of Delhi.
Unmute yourself.
Unmute.
Unmute yourself, Himanshu.
Himanshu, unmute yourself. You are muted.
Good afternoon, everyone. My name is Himanshu from Department of Mathematics, University of Delhi. I will thank to all the organizing team and Shikha ma'am as well. This workshop helped me very well. I learned a lot about Python. Before that, I was not able to understand any programming language, but from now I can learn some basic data structure and Python programming, and it will help me in analyzing some data from Excel to any using programming language. So I will in the last thank to Shikha ma'am also, because it was very interactive session as we were sharing our screen so that we can see and interact and participate in the workshop from away. So I will thank to all of you. Thank you.
Harshita, proceed further.
Okay. Thank you all. Now I would like to invite Professor P.K. Sisodia to conclude the session and the workshop.
Sisodia, sir.
Yeah, I lost my connection. So, I hope that you, all the participants, must have enjoyed your stay with this 5-day program, and as the you all will expect that you have done very well regarding that you're for the basic learners also, the Python as far as that you do programming, and I think Dr. Sikha has covered many aspects of that you're the Python language initially for data analysis. Regarding that you're the standard deviation, correlation between the variables, statistical analysis, exploring the data, etc. And finally, as I understand, she also talked about that the machine learning algorithm and for the classification of data, means covering many aspects of that you're the Python for that you're the data analysis. Hope you must have benefited, and I was expecting that some of that if there is some deficiency, you must also point it out that one also, so that for the next program or whenever we organize some other activity, we must take care of all that. Anyway, I'd like to thank all the participants on behalf of the Zakir Husain College, my personal behalf, and on behalf of the this organizing team. I would also like to thank Dr. Dheeraj, who is the program convener, Dr. Sunil from the Geology Department, Dr. Rakesh, Dr. Neelam Pahwa, and many more others, and the students, of course, those who are be associated in organizing this activity. Hope this will be useful for you all, and we meet sometime later for another activity. If you are interested into that one, we will be organizing many more activities under this DBT-STAR College scheme. So till then, I hope, I wish all the best for you, and you will be using your Python for your benefit of your careers. Thank you very much for participating and giving your valuable feedback. Thank you.
So let's have a photograph. Please switch on your cameras. Let me see the faces with whom I have been interacting online.
Yeah. Oh, Devan is also there. Okay, good.
Yes, sir. It was wonderful. Again, I would like to congratulate the whole team, sir.
Thank you. Dr. Dheeraj, you should also come. Sunil, Rakesh, those who are.
सर मेरा कैमरा कभी ठीक ही नहीं होता, मैं क्या करूं?
You always have behind the scene, organizing each and everything, and always behind the scene. Never come to the front. Okay. Sunil, where are you?
Sir, I'm at home, sir.
Oh, you are already there. Just have a different look. Okay, many more. Those who can switch on the cameras. So, Dheeraj, can you take these photographs and what the screenshots? That will be good.
Yes, sir. Yes, sir. I have taken.
Okay, so once again, thank you so much. Ma'am, Sikha ma'am, we are really grateful for you giving so much of time.
Thank you so much.
Of course, the participants also. Otherwise, without participants, it's difficult to conduct a workshop.
Yes,
and, yeah. Anyway,
it was a wonderful experience with all the participants. They were interacting, they were doing the work along with me. So it was really a very wonderful experience for me too.
Thank you.
Thank you, everyone. Thank you so much.
Thank you.
Thank you. Thank you, Sikha.
Okay. Yeah, one more thing, those who are present, that means we will try to send that to the electronic e-certificates for this benefits, those who have registered and participated throughout and has cleared all that the standards or that the essentials which have been fixed for the issue of that one.